Okay, so I'm trying out this new workout where I pull a 36 kilogram sled behind me. Now we know that the mass of the sled is 36 kilograms, and we know that I'm pulling on the rope with a force of 65 newtons at a 40-degree angle to the horizontal. Now let's go ahead and just draw our force diagram. We know that first of all, the force that I'm pulling with is this Fm, the force that I'm applying, so I just named it Fm for me. And we know that's 65 newtons. Now, we know that with the horizontal, it's going to be a 40-degree angle. Because of this, we know that there's going to be a y component and an x component to this force. Now, we know that there's a long distance force, which is gravity pulling straight down. We know that because it's a 36 kilogram force, that this mass times 9.8 will give us mg, which is 353 Newton force pulling down. We know that there's always going to be a normal force parallel to the surface, which is this normal force right here. Now, what are we looking for in the problem? We're looking for the normal force. So we're looking for the magnitude, actually, of the normal force. And we know normal force is along this y-axis. So let's look at everything on the y-axis. We know that this normal force is on the y-axis. This F component of Fm is on the y-axis, and also this mg is on the y-axis. So let's go ahead, and we know that this normal force plus this component minus this mg will have to equal 0 because it's in equilibrium and it's not moving along the y-axis. So we know that the normal force plus the force that I'm applying, the y component, which is Fmy, minus this the gravity force mg, will equal 0. So let's just solve for n. We know that n equals mg minus force, the y component. So we go ahead and we plug in the numbers. We know that n minus 353 newtons minus, and we know it's because it's a component, it's going to be 65 times the sine, which is this opposite side, times the sine of 40 degrees, and we end up with a normal force of 311 newtons that we're applying here. Now, let's say we want the acceleration. Well, first of all, we know that the F net equals mass times acceleration, but however, we know it's not accelerating along the y-axis, only along the x. So we know that the F net of x will equal mass times the x acceleration. So let's just go ahead and solve for x algebraically, or solve for a, algebraically, and we end up with ax equals the F net of x over m. Now, we know the only thing along the x-axis here is this x component of the force of Fm. So we can go ahead and just say that 65 times the cosine, which is this side, of 40 over this mass, which we have is 36 kilograms, equals an acceleration along the x-axis of 1.38 meters per second squared.